Welcome back to my channel Radha Maths Classes. Today I'm going to explain you question number 23 part 5th from exercise 6.2 ratio and proportion, and the question is if A, B, C, D are in continued proportion, then prove that A minus B upon C plus A minus C upon B whole square minus D minus B upon C plus D minus C upon B whole square is equal to A minus D whole square into 1 upon C square minus 1 upon B square. Since A, B, C, D are in continued proportion. Therefore, this A upon B is equal to B upon C is equal to C upon D. These three ratios are equal to each other, right? So, let us consider that value of each ratio is K. It means this equal to K, this equal to K, this equal to K, and this equal to A. Let us start from here. C upon D, it is equal to K, implies that C is equal to DK. And this B upon C, it is equal to K, implies that this B, it is equal to, actually I am transposing this C to RHS, that is CK. Now I am putting this value of C from here, that is B is equal to C means dk into k, that is dk square. The value of B is dk square, and also this A upon B is equal to k implies that A is equal to bk. Now I am putting the value of B from here, that is B is dk square into k, that is dk cube. Now I am writing like this: A, B and C. A is equal to dk cube, B is equal to dk square, and this C is equal to dk. Let this is the equation number 1. Now I will use this results in order to prove the question, right? Since the question is very long, so I am taking only this part first. This part, okay. A minus B upon C plus, sorry, A minus B upon C plus A minus C upon B, right? Now the value of A is dk cube, the value of B is dk square upon C is dk, plus the value of A is dk cube, the value of C is dk upon the value of B is dk square, here using 1, right? Now take out dk square as a common factor because D is here, right? And k is here, the least power is 2. You have to take the least power, k to the power 2. Inside the bracket, you will get this k minus 1 upon dk, and here take out D is here, take out D as a common factor, k to the power 3, k to the power 1, least power is k to the power 1, that is k. Inside the bracket, you will get this k square minus 1 upon dk square. Now this d cancels this d, this k cancels this power, and this d cancels this, and this k cancels this power, right? Now this k into k minus 1 plus k square minus 1 upon k, right? This multiply by k, and this k multiply by 1, that is k square minus k ones are k, plus I am writing this as k square upon k minus 1 upon k. This cancels this power. Now we are left with k square minus k square minus k plus k minus 1 upon k. This cancels this, and this k square minus k, 1 upon k. Now I am going to solve this part, right? This d minus b upon c plus d minus c upon b. D is d and b is dk square upon c is dk, plus d minus the value of c is dk upon the value of b is dk square. Now take out d as a common factor. Inside the bracket you will get this 1 minus k square. Again take out d as a common factor. Inside the bracket you will get 1 minus k. Sorry, I forgot to write this dk, this dk square. Now this d cancels this d and d cancels this d. Now 1 minus k square upon k plus 1 minus k upon k square. Now take out LCM of this k and k square. You will get this k square. This k cancels this k square k times, and we are left with k 1 minus k square plus 1 minus k. Now I am multiplying this k by 1, then k by k square. You will get this k minus k cube plus 1 minus k upon k square. K minus k and plus k cancel out, and you may write like this 1 minus k cube upon k square. Right? Now the value of this a minus c, sorry, a minus b, here you will have to write using 1. Right? And now this, the question is a minus b upon c minus a minus c upon b, a minus b upon c, a minus c upon b, positive sign, whole square, plus d. Actually there was minus sign and the question was this, right? Now I have found this value. The value is k square minus 1 upon k whole square, and the value of this expression was 1 minus k cube upon k square, this whole square, right? This k square minus 1 upon k whole square minus, you may write down that 1 minus k cube whole square as k cube minus 1 upon k square whole square, right? As a minus b whole square is equal to b minus a whole square, right? I'm using this thing here. 1 minus k cube whole square, I have written this k cube minus 1 whole square. The both are same, right? Now upon 1 k, LCM k, this k cube minus 1 whole square minus this k cube minus 1 upon k square whole square, right? This k cube minus 1 whole square upon k square minus k cube minus 1 whole square upon k to the power 4. Now take out this k cube minus 1 whole square as a common factor. Inside the bracket, upon k square also you may take k square. Inside the bracket you will get this. You don't need to write down this 1 upon k square minus 1 upon k to the power 4. K cube minus 1 whole square this k cube minus 1 whole square, and LCM of k square and k to the power 4 is k to the power 4. This k to the power 4 and this k to the this divides k to the power 4, k to the power 4 2 times and minus 1. Now this k to the power 3 minus 1 whole square and k square minus 1 upon k to the power 4. This is the equation number 2, right? Now on solving RHS, RHS is a minus d whole square 1 upon c square minus 1 upon b square, right? The value of a is d k cube minus d whole square, and the value of c is dk, yes, c square dk square minus 1 upon this b square means d k square whole square, right? Now take out d as a common factor. Inside the bracket you will get this k cube minus 1 and whole square. And now here 1 upon d square k square minus 1 upon d square k to the power 4, right? This I am removing this bracket, d square into k to the power 3 minus 1 whole square, and take out 1 upon d square and this k square as a common factor. You will get 1 minus 1 upon k square, right? This is d square cancels this k cube minus 1 whole square upon k square into upon 1, LCM is k square, this k square minus 1 Now this k cube minus 1 whole square, k square minus 1 upon k square bases are same, add these powers, k to the power 4. This is equation number 3. I have solved LHS and I have solved RHS. In both the cases, I am getting the same answer, which is k cube minus 1 whole square into k square minus 1 upon k to the power 4. And here also k cube minus 1 whole square into k square minus 1 upon k to the power 4. So from equation 2 and 3, from equation 2 and 3, we can say that LHS is equal to RHS proved. Thank you.